Good morning, ladies and gentlemen. My name is Dennis Poon. I'm the Vice Chairman of Thornton Thomas City Engineers with headquarters in New York and also with office in London as well. Today, I would like to introduce three panelist speakers. And first one is Mr. David Malone, Principal of Kahn Pedersen Fox Architects. And our second guest is Mr. Crossrail, CEO of the European operation of Parma Steel Leaser Group. And our third guest is Mr. Neville Granville, Director of Bentley Systems, the software giants. Today's discussion topic is what contributes most to sustainable design in tall buildings. Myself, I have involved with more than 12 super high-rise buildings over the world in different countries. From my experience, I find that doing tall buildings is not just have to be care about the architectural appearance, the height, or the energy assumptions. This is just one of the basic requirements. In the context of sustainable design, we have to care about the well-being of our occupants, our indoor environment quality, the impact on the wider community and the city itself with the tall buildings. This panel will also discuss and review the sustainable characters of tall buildings in the area of urban density, planning efficiency, as Mr. Peter Rees have mentioned today, the material we use in our buildings, the embodied energy involved with the tall buildings, the power generation sources, the power assumptions, consumptions, the building systems. These are all the focus that we have to review for our building design. And also, how are we going to integrate the skin and other sustainable design elements together in a huge project? Since high-rise building is involved with a lot of investment and many trades together. So with this, I would like to start my first 5 minutes of presentation. You understand that with embodied energy is the energy consumed directly and indirectly processed associated with the product or service with the boundary of the cradle to gate. You can see from our statistic survey, envelope accounts for 28% of the embodied energy in the project, the structures about 21, and so on. So you can see the envelope, the structure, and the finish all contribute to a significant part of the embodied energy. And after the building is complete, these elements will account for at least 20% of the embodied energy for the life of the building, especially the envelope itself. And for the embodied carbon is the related carbon emission associated with the production of the products. You can see steel is accounting for 35% and so on. This survey will give you a clear-cut vision on the selection of building materials when you plan for a building. Now, challenge of tall and green design. We all know that we have to deal with the carbon footprint. How do we do it as professionals? Starting from planning from the city itself, we have to be concerned, deal with the architectural forms. How do we maximize the form, the massing, and the density? The next, we have to deal with the structural efficiency. What's the best efficient system and the building material we will select to achieve our goal? We also will get involved with the advanced design process to optimize our building design in order to minimize the construction delay and field modification. That also costs money and also more carbon footprint. Very important is the efficient building envelope and the facade system, and also this other means of sustainable design to reduce the building energy, operation energy. Throughout several buildings, our Thornton Thomas City have engaged. Recently is the 634-meter tall tower in Shanghai. We're up to the 92nd floor already. The building takes shape. When we work out with the architect, the architectural form and shape plays a very important part. in the massing and reducing the wind load. We're twisting the building by working with Gensler Architect. We're twisting the building by about 110 degrees and also creating a notch at the building in order to reduce the wind load and the drag wind forces by almost 25%. That reduces, when we reduce the wind load, it helps us to reduce the structural system and save a lot of tonnage. And also for building material, because of the local availability of concrete, we're using a composite design with concrete and steel together. The next project is also dealing with architectural form, which is a 660-meter tall tower in Shenzhen, working with KPF, with David Malott's office and his team. We are also encountering the same effect with severe wind load with the shape and form. So again, on this one, due to the architectural reason, we have to not only taper the building, we have to create the corners of the building. We have to play around the corners of the building to reduce the vortex shedding. And this is a few examples that we deal with the building shape and forms. And also for the facade treatment, this is the other project is the 636-meter tall building. The Wuhan Greenland Tower is under construction right now with Adrian Smith Architects in Wuhan, China. It's also over a 100-story building. We are also dealing with the shape, and we are creating wind slots and also the curved corners to reduce wind load and cut down vortex shedding. And at the same time, the architect is dealing with the design of different sunshades and different curtain wall system. Similar to Shanghai Tower, we have a Doubleskin. So there are all kinds of means and methods nowadays that we can use to achieve our sustainable goal. And also with the new advanced software like the Tekla, the BIM modeling, the parametric analysis that we all employ in our use with the software, we can more accurately complete our tests. Now, I would like to turn the discussion to David Malone. I tried to go a little bit faster, so we will leave more time for the delegates to engage in our discussion. David?
Okay, thank you, Dennis. I'm David Malone with KPF. Okay, and it's a big question, what contributes most to sustainability in tall buildings? It's hard to answer with one word. So I'll throw out several concepts. And I think as an industry, we made great strides, I'd say, in the past 10 years or so in terms of understanding building performance and how to design buildings more efficiently in terms of energy operations. And I think even more recently, focusing on the concept which Dennis had mentioned, that of embodied energy, which for me is important. So the idea is to be sustainable, one has to start from the beginning and try to minimize the amount of energy and material that it takes to build a building. So I think those are two very key aspects of sustainability. And then the third, I thought about in context with this conference, being in London, and that's one of longevity. So obviously, the longer the building lasts, you're sort of taking the embodied energy and extrapolating it over time. Okay? And London has many, many great examples of buildings which were built a long time ago, which are still being used and still extremely relevant. Okay, so when I touch upon these points, I wanted to show a project that we're doing. This was recently completed in Hong Kong. It's called Hai San Place. Okay, it's a modern building that was done in a historic context, and historic being a relative term in the Asian city. So the buildings you see in the foreground were built in about the 1950s, but nonetheless, it's a very sort of charming part of Hong Kong's history. So in thinking about longevity, there's different ways that we can think about it. In sort of technical terms, one can think about initial build quality, how long the materials last. Okay? I wanted to focus on something which was more intangible, which is how long the building is relevant from a social or urban cultural context. Okay? And I selected this particular building because it actually replaced an older building which was only there for about 20 years, and it became obsolete. Okay, now this is not that building. This is something else. So this is the Kowloon Walled City, I thought this was very interesting because at KPF we've been talking a lot about density, sort of belief in the city as a sustainable proposition, okay? Mixed use. And this was a neighborhood in Kowloon in Hong Kong. It's since been demolished, okay? But at one time it was actually the most highly, in terms of density, the most populated place in the world. There's a little circles at the bottom of the graph. So Hong Kong itself is very dense, so 6,700 people per square kilometer. This walled city was almost 2 million people per square kilometer. Okay? To put that into context, you could fit almost half of the world's population in London. Okay? And in terms of a sustainable proposition, I would think that's very sustainable, right? Because you don't have the transportation, you're freeing up most of the Earth's surface for wilderness, something other than building. But of course, this itself wasn't sustainable because it was a concept that couldn't last. It didn't have relevance, I think, with our society and where we're heading. So there's a perception that it wasn't safe. There was a perception that it was, a place for crime, that it was dangerous. Okay, so I think for a project to achieve longevity, it needs to have this sort of cultural acceptance, or even in some cases the ability to influence our lifestyle and change the way that we live to head towards something more sustainable. Okay, so this sort of sums up the part T of the building. So the upper left-hand corner is it's the building that existed before we began this project. So it was a very simple extruded office plate, okay, sitting on top of a multi-level car park. Okay, and it was probably a building that was obsolete the minute it was finished. Okay, both in terms of it was sort of a product that wasn't required anymore by the market. The floor plates were too small. Okay, and in terms of urbanistically, it didn't contribute to the context. If anything, it was a urban divide. So it sort of broke up what had been a very sort of important neighborhood. So when we approached the new design, we actually looked at making the building envelope larger than the previous building. So the floor plates would be larger, more usable in terms of the needs of today's office space. Okay, but then to compensate for the larger building volume, then we punctuated the mass with openings. Okay, and then these openings were actually calibrated so that it would allow for the prevailing breezes to pass through and ventilate the two sides of the neighborhood, which had been previously disconnected by this building. And then in doing so, these openings then generated the public space for the building. So for me, quite interesting because it's a building which the formal response, the sustainable strategy, and the public space concept are all one and the same. Okay, so here you see programmatically, it's multi-level retail, okay, at the base. The purple is what we call flexible retail, so this could be either converted to office or stay as retail. There's even a scheme where you could convert the blue portion at the top, which is office, into hotel. Okay, so thinking about the long-term relevancy of projects, I think the capacity of a building to adapt for something that for changing needs of the future is very important, and that enhances its longevity. Okay, a few interesting things going on. In order to achieve the porosity, the elevator system for the office is a shuttle elevator on the side of the building. So you can see on the left-hand side this mast piece, which is the core of the shuttle elevators. And that transfers people to a sky lobby, which is above the retail. So this allows that porosity, allows the retail circulation at the lower levels of the building. And then importantly, it also introduces people at the top of the retail who can then filter down. Okay, and then this is the really nice part about the project then is these openings, which were originally intended to allow the prevailing breezes to pass through, then they become the social spaces of the project. Hong Kong, it's not dissimilar from New York. It's very congested and people want that release. And in New York, if any of you have visited, you can make a public space out of taking a street, partially pedestrianizing it, paint the street green, and throw in some chairs, and that's a public space. So in Hong Kong, I think it might not be a concept that could work in in London, the sort of idea of the Sky Garden as a public space that people would go to. But I think because the context is so congested that any moment of release is very welcome. And so I think mixing in these components with the building has led to a very successful project. So, maybe in terms of the aesthetics, not the most beautiful building that KPF has done, but I think certainly one of the most interesting. Thank you.
Shall we switch on? Well, what I would like to add to the discussion here is something from a point of an execution of the projects and the way we are approaching things. Of course, Permasalisa Group is known as the curtain wall company, curtain wall manufacturer from start till completion of a building. However, we do much more than this because we believe that investing in the product, in the processes we're doing, is giving our contribution to sustainability and to the future and eco-friendly or environmentally acceptable buildings as much as we can. Our organization goes back with a history of up to 145 years, so that's giving us kind of obligation to think about what we are doing and also showing that we can remain in business if we develop and question what we are doing on a permanent basis. So this is why I don't want to read it, but the mission, the commitment our group has is very much towards the highest possible achievements you can have. Our contribution seems to be limited, but on the other hand, it is growingly important and interacting with other trades. And for that, we definitely have to think about how are we doing this. And some items I've mentioned here are, of course, a very rigorous, honest, sincere quality control system we need to have. We need to invest with R&D in our future, in the product, in the processes, as I mentioned before. We are arriving at new technologies. We are arriving at new materials, substituting existing ones, and I will give you some examples later on. At the end, of course, we want to satisfy the needs of our clients and also of the individuals, the comfort of the people, the quality of living, and keep going with the next opportunities in the market. Again, here a summary that we think, and we do think it's very important, honestly, also that we need to consider our contribution from a sustainability point of view. If we want to categorize in maybe the three major items we are starting to investigate and develop things, one certainly is energy and comfort. This apparently and obviously is something which is there, which is in discussion and in development over decades already. But what we do see is that the working together, the collaboration with other trades, other engineers, starting from structural up to M&E systems, of course, is getting more and more important. And what we are doing, our response there is, of course, that we do a three-dimensional dynamic energy and thermal comfort analysis, for example, where we consider the interaction between the envelope of the building, which is the architecture, but much more also it is the first high performance element of a building needs to contribute and to interact with the other parts of the building. A result of this is we are developing systems, facade systems. CCF is a closed cavity facade where I think I can say this is a kind of second generation of the Doubleskin facades which have been brought into the market by us late 80s, learning from the experience, listening to the demand of our clients and architects. We see that there is improvements possible, especially in terms of energy consumption. This CCF facade is a very well-accepted product in Switzerland, for example, where they have extreme energy requirements, low energy consumption, the so-called Minergy regulations, and this is one example. Of course, we are thinking about renewable energy resources and control systems, for example, the blind system in a facade to protect the building, the owner, the M&E system from overheating is something we need to look at. Alternative systems and materials as a second field is something where we say traditionally there was steel. Later on, aluminum was available and is very common in our industry. However, I think may not be the end of what the base material of a facade construction, of a facade design could be. And we're thinking about substituting elements, substituting aluminum by polymer reinforced, glass fiber reinforced components, pultrusions. We have an example in our exhibition booth where you can see this can completely substitute the aluminum which we have used previously. Not to the same extent in every aspect of the characteristics and performance, but it is a starting point to develop further. A third one, safety and security. Of course, that's going back to long-lasting longevity of the building, security, safety demands in inner city contexts as well, where we say we are facing our envelope also dynamic loads, not only wind loads, which are dynamic of course as well, but also in terms of impulse and sudden loads like blast criteria. And we are developing systems to cope with this and offering solutions with a minimum expenditure on material and cost, of course, which is always the target of our clients, and a long-lasting building. If we look into a little bit more detail, again, a green building, many impacts like embodied energy. We have seen the envelope is the fourth largest contributor to the in terms of embodied energy, but at the same time it's lasting, it shall be lasting over a long time, over the lifetime of a building. Nevertheless, if I want to list some details of what we are doing actively, is of course recycling of materials. Aluminum extrusions today are almost 100% recycled or are available at 100% recycled if one is going for it. Embodied energy we talked about. If we look at the performance not only related to curtain wall, but to a big extent, of course, we can reduce the energy consumption for heating by better insulation, for electricity by better highly selective coatings in the glasses, for example, a better daylight use for less energy consumption in the building. Fresh water consumption is not so much related to curtain wall, but certainly also here, this is if you reduce the overall heating or energy balance of a building, you can consider this from a different angle. CO2 emissions, of course, when I was talking about process, when you are manufacturing the curtain wall, you also have to think about how you do it, what are the means, what are latest technologies. Waste and pollution, of course, latest when we do the process or internally in our factories or when we are on site, we have to consider that there is an environment that needs to be protected and safely used during the construction period. Operation costs, of course, is a heavily investor-related or driven aspect, which then should go along with the savings you can achieve in a building. Renewables is a matter that has been developed intensively over the last year. Renewables, first of all, everybody thinking about photovoltaics to generate electricity. Also solar absorbers, not only for heating or for hot water, but also for solar cooling is very common in these days. And also one of the topics we are looking at, for example, is wind power. All the high-rises, big buildings are exposed to enormous wind situations, and we might be able to generate out of this wind energy right at the building, right where the energy is there in a different form. Natural ventilation and user comfort, this is certainly one aspect. We want to, like Peter Rees or some others said this morning, we want to have the people in the buildings. We want to get them work in the cities. At the same time, we need to provide a certain quality of work environment, and this certainly can be supported by a proper facade design. Durability, again, the life cycle of a building, and last but not least, a certification which is not only giving an evidence, but should much more give us the driving force to move ahead. And I'm just listing here some. I don't want to go into details. Everybody here is certainly familiar with the most famous ones where we are trying to follow. with the procedures we're doing and the overall targets and goals our clients have with this. The facade contribution is significant. It's not the only one apparently, but it is a significant one. And in many aspects, we have seen that such tight coordination can lead to enormous results, and I will show some figures later on a very prominent building. Here, the Deutsche Bank headquarters in Frankfurt, the right-hand side, is a building which was built in the late 70s with at that time, a mechanically forced ventilated facade, and it had to be refurbished. And when the client, the Deutsche Bank, said, we want to refurbish this should be a symbol and a showcase what can be done and what the future shall be or could be. And when they have done this, not only the LEED platinum certification, they have published some figures compared to the previous operation of the building, that there was an enormous reduction and energy efficient move towards the next generation of high rises. Even though the design had to be kept, it was a desire by the client, the building is as modern as it can be and is as much leading as it should be, where they say 98% of the materials, and this was what I mentioned before, is coming from recycling and reusable materials. Not only the facade, the glass, the aluminum, but also the floors, the ceiling, the wood which is inside, the timber which is inside the building had been reused. And there was an obligation and commitment to provide evidence. 76% heating energy. I was giving I'm giving a reference to what it means. Just in those two towers, the heating energy could be reduced, which equals 760 private households per year, which can be saved. Electricity, 55%, again, compared to the private households, it's a rather significant number in my view. The water consumption of the building, by simply making it more efficient, better equipment, less need of dealing with pollution and air inside the building, was also significant with 74% savings on that. The CO2 permissions, again, a very significant percentage, almost 90% reduction, which could be avoided or will be avoided now every year. And last but not least, a better use of the office space with a high increased efficiency, meaning more work surface for the offices, is also something that increases the contribution to a sustainable design. I think those figures are very impressive. Maybe they lead to some discussions later on, but I want to close with this. Thank you.
Yes, Mr. Granville.
Okay, I'm going to take a few minutes to introduce who Bentley Systems are and what we do before I get onto the topic of this panel discussion. Within our tagline, sustain infrastructure, that's quite key for us. We provide software tools for our user base around the world that help deliver technology improvements in terms of their design, but help them provide sustainable infrastructure around the world. In terms of our activities, it's not just revolving around buildings or construction or day-to-day operations of buildings, but infrastructure in a wider context, from road to rail to pharmaceutical and process plant systems. In terms of our mission as a technology provider, we are very proud of our innovations that have taken place over the years. I just want to identify one or two that are quite important to me within the building and construction space. The concept of an I model is quite important from the point of view of sharing information in a mutable form, in a read-only form, and can easily be viewed and interrogated from a simple application as Adobe Acrobat Reader. So anybody, literally anybody, can view information that's shared on a project. Some other topics that I want to move on to, in terms of heritage and capturing the existing site information, our point tools and point cloud technology has become extremely important and relevant as we move forward. So the ability to capture very, very quickly an existing site or an existing heritage building situation and then transfer that information into the design context is very, very powerful. And that's become part of our pedigree now in terms of our software technology. And then finally, there was talk this morning about mobility. Mobility of people, and of course the relevance of buildings in their context. In the context of designing, construction, conceiving buildings, and delivering those buildings, information mobility is really, really important. So coupled with the concept of the I model, the ability to actually share and disseminate information very quickly, very easily, but also to be able to use tablet devices to actually review that information in a client meeting or a site meeting, capturing additional data. That's certainly where we're innovating. It comes on to a key point that I want to emphasize today. We're all aware of the concept of BIM and why BIM as a process is important moving forwards, and that's where our role is in helping you guys sustain create more sustainable built environments. But as part of our mission is to improve that efficiency of how a project team interacts together. And information mobility coupled with information management are absolutely key in the context of the BIM process. I just want to quickly touch on an awards event which we hold annually. And here are some of the winners from London at our awards from last year. Now, the reason I'm raising this, the actual awards event, the BIM Inspired Award events, takes place in a conference which for the first time we're holding in London. The Year in Infrastructure Conference is going to be in London later this year at the end of October. Crossrail is a key example. We're not talking tall here, but if you can imagine, you know, the height or the length of this, if we call it a building infrastructure, you know, the same challenges exist in a horizontal structure as they do vertically. And finally, I want to finish on the map of London. And many of the buildings that have been mentioned this morning and during the conference thus far, whether it's the Gherkin, the Leadenhall building, our involvement on the structural design systems for the Shard, for example, and our involvement in the London 2012 Olympics, those are key projects for us, and our technology has been integral in terms of the design, construction and delivery and day-to-day operation of those buildings and facilities. So in terms of the theme of this panel discussion, yes, we provide tools and technology that assist the architects and the engineers and the construction folks and the day-to-day facility management side of things in terms of building performance, energy analysis, structural design analysis and simulation. I just want to emphasize that BIM process yet again in terms of the importance of that as a process. With the UK government construction strategy and the emphasis that they've put on improving the way we collaborate and share information. And in terms of, you know, the one credential I want to identify today is our ability in information mobility and information management. Thank you.
Yeah, I would like to ask our panelists a couple of questions. First, I would like to start with Mr. Lofer from the curtain wall specialist. In tall buildings, there's a lot of surface area, and I've been dealing with the architect who specify and study different curtain wall system. Now, you mentioned photovoltaic cells in the curtain wall. How do you see the future of this technology being fully efficiently utilized in the curtain wall system? Because people simply, like in the curtain wall, they put patches, in order to keep it transparent, they put patches of photovoltaic cells. And I saw from Israel, there's another designer, they try to make the curtain wall more transparent by putting horizontal stripes of photovoltaic cells on it. since you're so involved in this area, how do you address this technology?
Well, maybe I should give a twofold answer on this, because one is certainly related to the business we're doing. The other one is maybe my personal attitude to it. It's if we look at the buildings, of course, there are many constraints under which a building is coming into existence. And at the same time, we're talking and striving for sustainability and eco-friendly buildings. But if we look at photovoltaics, there has been a huge development in technology and availability, and also in competitive and commercial terms. However, in a building, it has a limited, or can maybe only give a limited contribution to the overall idea. Because the orientation of a building, the verticality of a building, and also the total surface, even though we are talking about a lot of square meters, is somewhat limited compared to photovoltaic parks or something where you really can have a much higher efficiency. So I think having the technology available is very helpful and shall be one way of achieving a better energy performance of a building. On the other hand, it will have only a limited contribution to it. Nevertheless, we are of course also supporting this technology. We are developing organic photovoltaics, for example, which can give some color choice in the architecture, which can be maybe more accepted in terms of aesthetics on a building. Nevertheless, there's still a way to go to increase the efficiency to such an extent, and also the costs for production, that this will be applicable. So I consider this, in summary, as an important step forward, but with a portion and a proportional contribution on a building only.
Thank you. I will have a question for our architect designer, David. It's so important for you to design a beautiful building with the right massing that is sustainable, and you have to deal with the curtain wall system that has to be sustainable. You have to deal with whether you should be a double curtain wall system. If I have seen, it's getting more and more popular now. The Shanghai Tower has double curtain wall system, and even in London, I saw a lot of even the Leighton Hall Tower have double curtain wall system, and there are many other buildings. So this double curtain wall system, the curtain wall system with sunshades, with different density, with different slope and things like that. How do you see as an architectural designer, this kind of curtain wall design contributes or affecting your iconic building design?
Okay, interesting question, Dennis. And personally, whenever I hear the new technologies, I always have to balance it against, while it might improve the efficiency of the building, is it contributing to the embodied energy? So in other words, if you're building 2 layers of glass, the cost and the energy of that second layer, is it worth the energy savings that you would get? In return, I've yet to see any real scientific study done that sort of shows exactly where that payoff will be. I think the closest one can get to it is a sort of cost efficiency comparison in terms of when the payoff will be in dollar terms. I guess that's comes close to estimating what that means in energy terms. Because what I want to caution against perhaps is the aesthetic of green. In other words, that green itself with the double layers and the sunshades almost becomes an aesthetic that architects specify to make the building look interesting, say, rather than is it really required. So I think the architects need to ask hard questions of themselves. Is it worthwhile? And I think certain innovations that Premise Elisa has been doing, like the closed cavity facade, sound very interesting, because I think it's, rather than the double layer facade, now you're optimizing on space. It's beginning to, I think for me, become a more sustainable proposition. But I think we need to sort of, as architects and designers, move beyond green as an aesthetic and really think about green as a sustainable proposition.
Level, since Bentley Systems is supplying us all the software, my question is that every time when I learn the software, you have a new one coming up. And the other thing is, I also learned from my engineers that they have difficulties of integrating this software together, and also how do we interpret extrapolate one software with the other software. What kind of work you'll be doing to make it more user-friendly?
Okay, well, Dennis, you've probably encapsulated 3 or 4 questions there, all wrapped up in one. Just starting with your first point about constant change. You know, there's constant change in the design sector. There has to be constant change in the software development sector. And you know, our research and development folk will engage quite often and quite regularly with industry professionals, and that's really quite important. Whether we get it right from a usability point of view and the user interface point of view, that's a constant challenge. You know, we're not only compared today with our peers in the industry, other software providers that service our community, but we're also compared with gaming software providers and the experience that we have on mobile devices and mobile technology. We expect so much more from a desktop type application. So that's a real big challenge for a company like ourselves to constantly move. But I think the most important aspect of our technology development is the R&D folk. You know, those guys are reaching out to industry with our own ideas as well mixed in terms of how do we improve the design professional's life in terms of enabling them to achieve better design, more sustainable design. You know, that it's the R&D folks that really are key there.
Thank you. David, there's so many strategies in the sustainable design element we have to integrate together. You have the advanced mechanical system. I'm sure there are delegates here are expert in mechanical engineering. They would like to get their mechanical system into your building. And then we have the greatest curtain wall system with low E glass and double pane glass, triple pane glass, and so on and so on. And also you will be constantly hassled by the structural engineers trying to get the most efficient structural form in order to save building materials. How do you handle this and balance this act together as a designer?
I start with structures, Dennis, of course.
And also, how about the massing, okay? Because right now, many years ago when we deal with architecture, when we're using, before we have the AutoCAD, people do it by hand. Now with the computer system, the architect can make changes and design so many schemes so quickly. With these tools, how do you see the future of architecture rather than more iconic, I would say more rational or irrational shape? How does sustainable design place any restriction on your freedom of architecture?
Okay, I think what we've been doing recently is that design is becoming even more iterative than it used to be, particularly with the help of the computer. And I think what Dennis was referring to is my particular focus is how to take a building form, optimize it, rationalize it, so that from the very beginning the structure makes better sense or it's better tuned to the environment. So we can take a massing concept and with the computer set up a few parameters, what we'll allow, how we'll allow it to vary, and then just let it iterate, like a computer playing chess. You just do 20,000 moves until it finds one good solution. Actually, we're doing projects with TT where we'll set up a design in Grasshopper. They'll set up their structural model in Grasshopper. We'll iterate, and as we're iterating our model, they'll be iterating their structure until we find a solution that is going to save structural cost, right? Which I think is equivalent to embodied energy. Okay, same with curtain walls. So we'll take a look at how subtle changes in the building massing or orientation will reduce the energy load on the building, or fins of varying heights or widths, positions. And so I think we have far better capacity now to sort of tune or calibrate a building. And so our job as architect is changing a little bit. So there's no absolute answer. We don't quite sketch the solution on a piece of paper. In a way, it's more like we're directors, if you would. So we know where we want to head. okay, and it's sort of leading this process. Okay, so I think that's fundamental change in the design industry, and I think it's a positive one.
Thanks. Mr. Lothar, when we design or the architect specify a more efficient curtain wall system, it also will lead to a higher cost, initial investment cost. From most of your recent project for sustainable high-rise building, what kind of feedback or resistance from the owner side you will feel when you are proposing a more expensive but yet more efficient and more sustainable curtain wall system? Do you think that they are buying more into it and more willing to invest more into this sustainable curtain wall system?
Well, first of all, I think there's not an automatic link that if you do a better performance, it costs more. I think maybe you spend more on the facade, but maybe you can save somewhere else. So I think what is important, if you want to get there, you have to start early on and to get all the disciplines on board and to think about the best solution. Facade has a heavy interaction with the M&E system in these days. Facade, of course, has naturally the envelope of the building for the architect. It has the importance. So I think what is helpful to at least not to create a premium necessarily is to start with a convincement and an early phase to start working on solutions. The second part, what you're saying is there more demand, more acceptance? I think it depends also on the approach of the clients. The majority of the buildings, I think, let's be honest on this, is very economically driven. So, which is right and which is correct, but the philosophy behind the building must be prepared for a long-lasting and sustainable building. If an owner builds for himself, it's certainly different than building a speculative building. So with market demands and tenants available or not available. And I think we at least see that the awareness, the willingness to think about the contribution or the long-lasting performance of a building is increasing in general, the tendencies there.
Good. One follow-up question. For your curtain wall design, you usually have to work with the mechanical engineers for the energy studies. What kind of steps usually, the best recommended procedures you would like to work with the mechanical engineers when you guys are designing the curtain wall system for the energy studies?
I think what we are seeing is that the system or procedure I would like to see is certainly one that you're ready to change. Because we see, and this is not an interference, but this is something which we have had in our philosophy for a long time, that we see that a facade can take over certain functions of a building which were taken over by a mechanical system in the past. So I think the readiness to discuss and question what we are doing in order to have a better result. This is the procedure. But again, then this needs to have somebody with the enthusiasm and the will to do things better.
I think you need a lot of collaboration, teamwork.
Absolutely,
at a very
absolutely.
early stage.
But overall, in all the construction, I think also a structural system needs to interact and collaborate much more than it was in the past.
Mm-hmm. Thank you. Neville, with the Bentley system, there's so many software. And I understand that everyone in each of our office are using different software and so on. And also in different countries, depending on the economic situation and the availability of the software, it will put us into a different trend to our design. What do you see in the field of software that benefits the more common widespread of energy study programs?
Okay. Well, I guess the first thing is to provide a tool set which is relevant to the individual disciplines for their own analysis and simulation in terms of building performance. Typically and historically, that's been the domain of the M&E engineer to look at building performance. But as we move forward, and, and a point that Klaus was touching on there in terms of closer collaboration often takes place. So the architect, the structural engineer, as well as the M&E engineer, all need to work more collaboratively together earlier in the process and using similar kind of tools. So the act of building performance doesn't start at the M&E engineer's phase. It starts right at the very beginning of the process of the concept of the building on the site. And we need to evolve our technology so that those tools are ready to use by the other disciplines that perhaps not as familiar with the process initially, so it needs to be easy to use, et cetera, et cetera. So yeah, it's one of those moving, ever changing and moving feasts of our own internal development and keeping up with the way the industry evolves itself.
Great. Now we have about half an hour left, and we have a lot of delegates here who have a lot of experience in the sustainable design. I would like to take some questions so that we have a more interactive sections to discuss this topic. About this, the lady.
Yeah, thank you for the presentation. It was very good. I wanted to know about the double-skin facades, how efficiency and how sustainable it is to be used as a cooling strategy for like semi-arid climates. So like it can be used for like continental climates, but how is it like in arid climates? What's your view on that?
Well, I think the double-skin facade, there is the definition of, you need to understand what it means. Assuming that you're referring to an externally, naturally ventilated double-skin facade, I would say that there, of course, you have to study in each location, geographical region, what the performance can be. The physical performance of it is easy to calculate. However, if you look at the practical use of the double-skin facade, the extreme climates, extremely hot or extremely cold, are the ones which are helping. Then you're very close to a calculation point of view, but not increasing the efficiency or the sustainability and energy conscious running of a building. So if you are in a moderate climate, you should be able to find enough reason and basis to still use it in a very big portion of areas or geographic regions. Even in humid climates like the Far East, we have done a lot of studies, but then on top of the pure performance, the users' demands and the investment can be totally different compared to European climate, for example. And I think that's where also main reason is, besides the physical performance and the technical performance, that the expectation of a building varies quite a bit in each market. But at the end, I think double-skin facade is a very good way forward, or it's there for 20 years now, to improve the performance and also the comfort inside a building, which is of course still a factor which can be engineered.
Great panel. Thanks for sharing. We do have here a technology provider, building product provider, architect, KPF, and a structural engineer, Dennis. Last CTBUH Shanghai, a question was posed: what can be the tallest building that can happen? And the answer was 3 kilometers, replied by architects, structural engineers, and elevator companies, if I remember it right. But the mechanical, electrical, fire protection, they say we should limit it to 1 kilometer. No, not beyond that. Now that we are in London, what would be the optimum sustainable building height that you may want to guesstimate or put forward to make it sustainable, not beyond X number of meters or feet or what?
David, try this question first.
So I think maybe this one goes back to my point about the lifestyle as a factor in sustainability. So The answer to your question would be it's only as tall as people are willing to accept for now. Okay? I think that height can keep rising in the future as people in London get more accustomed to living tall. Right? For the longest time, the tallest structure here was St. Paul's. Right? And even the current wave of high-rise buildings being built in downtown, I think, probably started out very controversially. So,
Like the densities of Hong Kong. If we have the residential density of Hong Kong, all the world's 7 billion population, we can all fit in the state of Texas.
yes, yes. So I think for me, height and increased height is inevitable. But I think it has to go along with changes to our lifestyle. We have to grow into them. Because, I mean, one could build a kilometer tall in London today. I mean, technologically, it's no problem. But would people live in it? Would people lease it? What would people in the city feel about it? I think those are the things that need to change before the technology does. The technology is already there.
To answer your question, structurally, indeed, Thornton Thomas City have done design and real depth design for towers for more than 1 kilometer tall. We have designed buildings 1 mile tall before, and that building is supposed to be built in the Middle East until the crisis, the financial crisis, hit that region and hit the world. So that 1 mile tall project was suspended. So technically, I think with all our colleagues, I think you know that we can design and build buildings up to 1 mile tall, British mile. However, as the city planner this morning, Mr. Peter Reed said, it's not how tall you are. The height is only relative, okay? From the Lloyd's of London building, 95 meters, to the Gherkins of 180, right now to the Shah building of 300. I mean, that 300 meter may not be meaningful later on when someone builds another 400 meter tall tower in London, somewhere in London. But the key word is, how does it adapt to the city? Does it fit into the city? What people can digest and make it useful. I think that's the key. And I think technology-wise and ability-wise, we can handle it.
Hi, my question is, I'm Vineet Khanna, architect from India. Extension of what the lady asked. We belong to a country where we like a lot of fresh air. And it's a question for David and Mr. Luther to sort out that when we studied architecture, we just studied door, window schedules. There's no mention of glazings. When you talk of windows, you talk of opening. And whosoever structural glazing designers and implementers I meet, they are so resistant to make openable windows so that you can't breathe. When you put a glazing on a person, you feel you are insulated in a space suit. So why is there so much of resistance offered by structural glazing people they say it's expensive, it's not required, we better pump in more on aircon and not have fresh air. Like Hong Kong, I mean, David would agree with me. If he made such a good breathable building, why can't it be more breathable with kinetics of glazing in today's day and age with space shuttles and all? Why can't we have fresh air why can't we breathe fresh air? And in a country like India, our air conditioning teacher said, we don't require air conditioning in homes. So why can't we breathe fresh air? And it's a challenge for the structural glazing designers to have this kinetic openable component, and which is like, which is okay, it can be, let it be, let's take it easy.
No, I think it's a very valid request, and I think it's gaining traction. I think more and more people want natural ventilation in the tall building, and there's technical difficulties with that, but we're certainly making an effort to do that. The project I showed you in Hong Kong and many cities in China actually require operable windows in their code because people want them. And actually, we did that project with Mr. Lisa. And in Hong Kong, it's not advisable just to have a window that opens because it's quite probable that window would get blown out in a typhoon. So instead, it's ventilating through the mullion. And in that particular building, it's you hit a button, it's kind of cool, and then the floor kind of flaps open like this, and you can actually feel the breeze come in. You can hear the traffic from the outside. It's regulated, though, because the humidity in Hong Kong, it wouldn't be practical to do that all year round. So when it's very humid, you have the AC on. If you let that warm, humid air in, then you get condensation, for example, on your ceiling. So it has to be controlled. But I think as human beings, we want that contact with the air. I think now we're beginning to develop technological solutions how to achieve that. But I agree with what you're saying completely.
Yeah, but technically there's still some questions. We're doing a lot of window node tests. When you open the window on the 50th floor, it affects the whole balance of air. You have pressurized air, the elevator shaft, you have stack effect rising up, and it really affects the usage of the building, the mechanical system, and the fire system, fire resisting system. So it is a good idea, but we still have it has to be planned very carefully when you have operable windows.
Yeah, David, I'm glad you answered the question about the ventilation, because that's quite a clever thing that you've got there in the building in Hong Kong, which I enjoy. But I have another question about that building in the context, the urban context. You've got the sky garden and you have the ventilation from one side to the other. That's wonderful when you have that very low-rise environment around the building. But as we know, Hong Kong builds up very rapidly. Has there been any consideration in the design of the building for what might happen when there are more tall buildings built up on the surrounding sites?
Good question, Moria. I don't know the answer. I wasn't directly involved in that project. I do believe, though, that the picture, the image I showed you with those buildings in the foreground, those are landmarked. So there's an effort to try to preserve those buildings. In Hong Kong, one never knows, right? Because I think just the demands on the land are so intense that you're right. I think in the future it could be built up. But it's a good point. It's a very good point.
I wonder if you studied energy optimized facades, things like optimizing the amount of energy use. Obviously, the more glazing you have in a building, the more energy you'll spend on air conditioning and maybe heating. But on the other hand, the more you'll save on lighting. And I wondered if you've done studies on the optimum annual energy use for facades in different climates, assuming it's a simple facade without a double skin, without too much shading. And sorry, to give you a clue to the answer, the lead energy calculation assumes a baseline of about 40% glazing as a percentage of the facade. And the UK building regs seem to start with a baseline of about that much. And yet just about every example we've seen today starts with 100% glazing. And I just wonder if we're looking in the wrong direction.
Well, this is probably since there's several aspects which come together if you start to design a building, and there is of course the glass and the energy amount you're gaining in a building through the glass is an apparent discussion which needs to be addressed. On the other hand, we have seen that the development in glass coatings has given a lot of opportunities to reduce, and this is when I was talking about selectivity of glasses, means a high light translucency or light transmission by gaining minimum energy inside the building. But of course light is energy, and as long as you want to have light in a building, you find energy inside the building, and this is a matter that is a given fact. We certainly have, this is a pure calculation matter. We certainly can put it in ratio to each element, how much glazing versus opaque elements could give an optimum ratio and performance from that aspect. But I think that's not the approach we're having. We're trying to find the most suitable and most the best performing materials, given that there are many parameters like the architecture, of course, like the climate, of course, the need, the user type of the user inside the building, where you can probably run the calculations easily. I personally don't have the number ready, but that shouldn't be a difficult exercise. But I think the bigger challenge is to find a solution to the building, to the demand of the user and the owner of the building, whilst keeping the architecture. And this may mean adding components like the sun shading on the external, for example, instead of the internal where you already have the heat inside. If you put it outside, maybe you have to add another layer of glass on the double skin, or maybe you capture the blind in a closed cavity, as I mentioned earlier. So there are means of bringing back the optimum performance to the desire of maybe having large glazing portions on a building.
Yes, sir.
Another question for Mr. Klaus Lotter. Among the buildings you showed, one is located in Milan, Porta Nuova. It's 2 towers, twin towers. They obtained a mention with the CTBUH in Chicago last year, and it's a retrofit of 2 towers of the 80s. Now, when you, in retrofitting, of course, the structure is already there, and I imagine that it's still worthwhile. So the question is, what was the role of the skin that you substituted? I mean, how did you make it sustainable, and how did you upgrade the standards so that it would even be a good investment, you know, so that it would become a modern building and a good investment for the client?
Well, on Torre Garibaldi, I wasn't involved in all the process, but if I can say from other experiences, I think we're seeing 2 different aspects. One is, again, or different approaches. One is, again, that there is a clear specification what it must be afterwards, before and after, or there is an involvement where you can say we design it to an optimum solution. In most of the cases, to be honest, it's the first one where we say, okay, the glass needs to, instead of single glass, must be double glass. The glass coating must be low E plus sun protective coating. So there are detailed performance criteria which need to be included. This is the most common and the typical approach. On other buildings, like the Deutsche Bank is one of them. Of course, we had been involved in defining the solution. There was no performance specification. We have done the performance specification together with the planner and the architect to develop the best solution. Of course, there were other constraints that the profile shape was not allowed to be changed, even though it's triple glazed now instead of double glazed, or it's openable now instead of fixed glazing. So this is the other end of the approach, where we say this is where we can certainly gain more benefit for building, and the numbers you have seen are certainly impressive in terms of the change you can achieve from an old building to a new building. But in between, from remaining with an old building and this extreme, anything is possible. And there's certainly examples where we are involved as a company only for doing reglazing. We are only doing the craftsmanship of the refurbishment. On the other hand, we are also finding opportunities where we can bring in ideas. We can put in heating into the facade, whereas it was only a pure frame for the glass before. We can add sun shading devices, and that's, I think, very different from each building. Like also the St. Guy's and Thomas Hospital is changing the architecture whilst the building is in operation, but modernizing the performance to some extent, but not to the maximum extent. This is a combination of.
I have a question about sustainability generally, because sustainability, I think, can be measured. You know, how do you measure it? What does it actually mean? And of course, there's tools out there like LEED and BREEAM that can be one ways of measuring that. So I have a question for David about: do you find these certifications a hindrance or a benefit in designing buildings? And do you think they're moving fast enough for you to realize what you want and show the credentials of sustainability?
Okay, I think for me, I think LEED and similar benchmarking systems have had a really good positive effect. I think purely from an engineering standpoint, I've heard some people think it's too simple of a metric to really create a sustainable building. On the other hand, in terms of what is done from the owner's perspective, in terms of getting building owners and developers sort of on board with sustainability has been extremely influential. In China as well, they're adopting LEED. They have their own Energy Star system. And then now the whole industry is catching up. You can't get a bank loan for a project unless you're heading towards LEED certification. Certain tenants, because of corporate responsibility policies, won't occupy space unless it's in a LEED building. So I think this is the real contribution of the benchmarking system. Okay, that being said, I think if we just design to good practice, you're probably already at the LEED Silver status, and if you design to good practice per CTBUH standards, you're probably at gold. The project I showed you in Hong Kong is platinum, so it's the first platinum building in Hong Kong. But I didn't even mention that. I forgot to mention that because it didn't seem like that was the most important thing in terms of a design target. So I think for me, it's less about what LEED and BIM and these systems do for us during the design phase. It's more for what it's done for the owners in the industry.
I would like to second that question you asked, since David mentioned about the certification system. The LEED has a different matrix giving you the score points. And if you go to Indonesia, there's another scoring system. You go to China, another scoring system. It depends on basically what is more urgent in that country. They will push for something. Like in Indonesia, the energy cost is so expensive. They will give you a higher point for the energy and atmosphere savings. That the more energy you save, the higher score they will give you. So it varies from city to city. However, as we're moving forward, I think right now, most of the design professionals designing major high-rise building have been doing much more than what the matrix is calling for. If you look at the scope of work of sustainable design, in addition to architecture, we don't just do architectural or structural engineering or curtain wall. We have to start a lot of analysis with the site analysis, the orientation analysis, the massing study, the daylight strategies, the natural ventilation analysis, energy studies, and so on and so on. All of these are part of our sustainable design. We're going into a high-rise building. So it is way beyond what Matrix is calling for.
Yeah, I have a small question for Dennis and David. When you design such tall building, do you think about what will happen after? So it means that one day, a huge amount of this building will not perhaps fit anymore with the social requirement and with the local society. So when you design it, do you think, okay, how can I dismantle it? What will I do with the material when I will dismantle the building? Thank you.
You want to start, Dennis?
I think when you design a high-rise building, it involves a huge investment. So usually the design lifetime, the payback time for a high-rise building is definitely more than 10, 15 years. So when we design a high-rise building for a super tall, we even design for at least 100 years lifetime. However, for the mechanical system, since the technology of mechanical system is evolving, I would say every 5, 10 years, it depends on the investment. I'm not surprised that building owners will continue to upgrade the mechanical system more often. But for the curtain wall, even the caulking of the curtain wall will give you 15 to 25 years guarantee. I don't see curtain wall replacement will happen so fast. Just look at the CS Tower. They have been talking about at one time to use photovoltaic curtain wall panel. It has not been materialized because it's a very expensive option. But I will not be surprised that the interior layout of the building will change to accommodate the use and the evolving mechanical system.
Yeah, so when I think about these buildings, I try to design them as modular as possible. And maybe it's not necessarily so it could be dismantled, but the idea would be it's adaptable to any future use. Okay, so the buildings, I think there's a danger when the building design or the building form becomes too specific that it can only be used for one thing. So I think a lot of the buildings, the ones I've been working on with Dennis in China, it's very rational. It's modular. It's it could be an office one day. It could be converted to a hotel. Curtain wall could be completely removed, and you could put up a new envelope. It's really the structure, I think, that one focuses on as being having the longest life cycle in one of these buildings. And I think it's just this year, the 100-year anniversary of the Woolworth building in New York. So it's at one time the world's tallest building. And it was designed as office, and now it's being converted into residential. So I think there's something to be said of a building that's well put together and rational to start off with, and then as future needs change, then the building itself can adapt, as opposed to, say, taking it down.
So I never argue with the architect when they suggest to remove the columns in order to create more column-free space. Just to answer your questions. Yes, please.
I have two questions, probably for Klaus. First one's moderately technical. I wondered if you could tell us how a closed cavity facade system compares in performance terms to, say, triple low E, double glazed units, and not only the performance but also the additional costs that you need to pay for a closed cavity facade system to get that performance. And the second question, which is probably to Klaus and perhaps David, you want to comment, is how you feel about embedding photovoltaic technology into a facade, which has a design life of 25 to say 50 years, when photovoltaic technology is rapidly improving its performance, and really every 5 years it completely at least doubles in its performance. Just how you feel about that. Thanks very much.
Maybe the technical answer I try to give without going too much into detail, but it all also depends where you start from. You cannot compare a single skin with a triple skin. This is you can do a physical or analytical comparison, but I think this is not, you will never choose between a single skin and a triple skin. You need to decide which way you want to go. Nevertheless, if you ask for performance criteria, a CCF, a closed cavity facade, for example, in Switzerland, today we are achieving U values of a fully glazed facade of 0.6 watts per square meter Kelvin. This is basically the performance of a triple glazed unit, including the aluminum extrusions. So this is certainly opening a path through a high-performing, in terms of insulation, a high-performing element, by still gaining the full transparency for the architecture, for the use of the building, adding then again sun protection by a sun blind, which of course you don't need on a single skin with highly reflective glass. You're adding it, and also you're adding costs, of course, but you're changing not only the appearance, you're changing the value of the building, the quality of a building, the quality of the use of a building. And of course you can calculate, say, triple glass is, I don't know, 80 euro per square meter, and double skin is adding one layer of glass, and a sun blind, maybe you're ending up at 150. I don't know, just as an example. But this shouldn't be looked at completely isolated. The performance can change dramatically. But of course, when you're closing a cavity, for example, you have a heating up in the cavity, which you need to properly engineer, that you're not creating surface radiation on the internal side of the building, which then is harmful to the use of the building. So it's not an easy exercise. Probably also the answer is not so easy, therefore.
Hello, Russ Timpson. I'm the Secretary of the Tall Buildings Fire Safety Network. The point of this conversation was the greatest contribution to sustainability. Would the panel agree that for a building to be sustainable, it's got to be perceived as being safe? And as we're currently suffering worldwide a serious tall building fire every 8 weeks, and some of those fires are involving the whole of the facade of the building when they do catch fire. Listening to the panel talk, for example, photovoltaic cells on the outside of buildings is posing real problems now to firefighters when they're called to buildings. Penetrations of facades leading to wind-driven fires at heights above 30 floors, which totally undermine some of the fire strategies that are in buildings. Would the panel agree that safety is probably the greatest contribution to the sustainability of a building that's going to be used for a long time?
Well, no doubt about it. When we design a building, the safety has to come first. We have to meet the fire codes and the structural requirements and the mechanical safety requirement. There's no compromise on that. if there is a concern like that you have raised, that should be addressed first, rather than just purely based on saving the energy costs or the money to build something in a less superior grade that will compromise the safety. To answer your question, I have not seen in our design team any efforts to compromise safety of the occupants at all. As long as we know about it, okay? Unless this is a new, for example, like curtain wall caught fire. It happens in China before they burn the whole building down because it's due to the insulation they use in the curtain wall that is combustible, which is banned in the international market, but unfortunately is being used illegally by the contractor. So this kind of thing is not tolerable in our profession. For all of us, if we know about it, we should bring it up to our attention. Just today's topic is what contributes most to the sustainability of tall buildings. As you see, all our panelists have pointed out so many elements in our design consideration that we have to study, we have to exercise, we have to perform. I couldn't single out a single element to say this is the most that contribute to this sustainability. But one thing I would like to ask you to see if you agree is that we are nowadays, for every project, we're working as a team. I think the team effort together to integrate all kinds of sustainable design measures is the most that contributes. Without a team effort that will interact with each other, we will never be able to design the most sustainable building. Then with that, I would like to conclude today's panelist discussion. And I would like to thank our panelists, David, Klaus, and Novell. Thanks for coming.